Welcome to the Code with Jason meetup. Today we're going to work on some more testing and OOP stuff as we have recently a few times. I'll share my screen here and kind of describe um, what I've been working on. And by the way, Scott, you said you found my website a few weeks ago. Do you happen to remember how you found it?
I believe, just looking at some Ruby on Rails material. It's been years since I've jumped into Ruby on Rails, but it's always been my favorite framework. And I think I came across some Ruby on Rails testing articles from a Google search.
Okay. Yeah, not too surprising. That's a lot of my blog posts are on that topic.
Yeah.
Um, So what I've been working on for these last few sessions, on and off, is some lessons around object-oriented programming. There's definitely testing involved because that's just how I code. But the main thing that I want to share is not necessarily the testing, but the object-oriented structure of the code. Um, and I'm actually going to take this code off the screen because it's not relevant right at the moment. Um, And I think the most important idea in any kind of programming, object oriented or not, or at least one of the most important ideas, is what I call wielding the analytical knife, like taking a domain and slicing it up into concepts that make sense for the purpose. I've used the example several times of like a motorcycle. You could conceptually slice that up into the electrical system, the fuel system, the braking system, stuff like that. Or you could slice it up into like parts that are made out of metal, parts that are made out of plastic, parts that are made out of rubber, that kind of thing. Different ways of slicing that up could make sense for different applications. Um, and the program that I'm working on now is an expression parser, a program that parses a mathematical expression. And I can show real quick some of the specs for this. Um, Basically, we take an expression and parse it into a tree structure. So if we have, like, for example, 2x plus 5, yeah, here we go. We have 2x plus 5, for example, plus would be at the root, and then the right-hand child of 2x plus 5 would be just the constant 5. And then the left child of this tree would actually be a subtree where the root is the multiplication operator. And then since it's 2 times x, the two children would be 2 and x. And so the objective is to build a program that can parse basically any kind of expression. And Omar, did you finally get connected to audio successfully? We'll never know. Okay, and here's an example of a more complicated expression. This is 3x squared plus 5x plus 1. Oh, great. Amar can hear us.
Cool.
Um, so here's this, and I have this program a certain way built. I have like 24 tests and they all pass. I'll just walk us through a few of the tests real quick. Um, if the entire expression is a constant, and by the way, some of these descriptions I'm realizing right now are off. Okay, so the expression is a constant. The number 5, it just gets 5 at the root with no children. It has multiplication with an explicit operator like 2 times x. We get a tree with times at the root and then 2 and x as the children. And most of them are fairly banal um, scenarios like that. X divided by 3, you get the division operator at the root, and then x and 3 is the two children. But then one of the more interesting ones is here we started dealing with parentheses. So 6 times x plus 3 should get parsed into, it should have a root of times because it's 6 times x plus 3, even though there's no explicit times operator. Then the left child should be 6 and the right child should be plus because the right child is this subtree x plus 3. I'm going to commit this change I just made. Okay, and let's look at the code. For one, I just have this very simple data structure called an expression tree. If we wanted, we could have just called it tree because there's nothing expression-y about it. It's just a tree with a root, a left child, and a right child. And then we have another class that represents an expression, kind of. So you can see on our tests, we're doing like expression.new and then passing it a string representation of an expression, and then we can call .parse. So that's what this class is all about. And you can see basically everything it does initializes an expression tree. But I'm not super happy with this class as it is right now. Because look, it has this giant parse method. And Scott, I'm actually glad that you've never seen, well, I assume you haven't seen the previous videos. Uh, I'm glad you've never seen this code before because you won't be cursed with the familiarity with this code. And so you can be baffled by it because it's not very easy to understand. And so you can tell me, or you can help me understand like what is not clear so we can kind of refactor it.
Yeah.
So hopefully this top level API makes sense to you. Expression.new 2 times x dot parse. Straightforward enough, right?
Yep.
But then things get ugly in a hurry. When we look at the parse method to see what it does all this stuff. So here's what I'm going to do, Scott. If you're game for it, I'll have you go through bit by bit and you can try to explain what each piece of code does. And if you can't figure it out, that's not your fault. That's my fault. And that's a sign that I need to improve the code. How does that sound?
Sure. Yeah.
All right. All right. Let's start from the top of this parse method.
Okay. So you've got that at value.strip. You're clearing some white space.
Mm-hmm.
Uh, and then you're handling the case where it's a constant, right? So
Mm-hmm.
we're taking the value and we're initializing a new expression tree with a root of that value as an integer
Mm-hmm.
in return. So we're cutting short there. Then there's the um, value dot length is 1. Okay. That is just going to return the same value dot length. So that's a just a 1-digit integer, I suppose.
That
Uh,
is wrong. So this is the first example of something that could use improvement.
hmm,
And I'm realizing right now, this wasn't very clear to me before, but now it's kind of clear to me. I can say this.
yeah, there we go. That makes sense. So if it's just a single variable, right?
Hmm. Oh, and look at this. This is dumb. I'm passing the value, but then I'm referencing at value.
Yeah,
So that's like illogical, but I'll deal with that in just a second.
yeah,
Let's run the test. Okay, they all still pass. So I'm going to commit this change. I'll just say refactoring. It's pretty clear from the change what it is. Um, and then I can fix this. One way to do it is I could go like that.
Yeah.
Hmm. But I'm not sure. It might actually be clearer to do this because then it's more clear. Because if we just have this, it's like if constant, if variable, like if what is a constant or what is a variable, it's not that clear. But if we
Mm.
pass the value, even though mechanically we don't need to, um, it makes it more clear what the subject of the question is. So I
Hmm.
think I prefer that. I'll run the tests. They all still pass. Um, I'll commit that. Okay. So we have the constant and the variable cases. What about that next chunk there?
So if the value includes a parentheses, this is handling your parentheses test case. There's a left child and a right child
Mhm.
uh, that you are going to split on. And for, let's see, so you're going to split on the parentheses, and for each parentheses, you're going to extract that value and create a new expression, one for the left, right, and one for the right. Um,
Yeah. Well, this is a bit noisy, isn't it?
yeah, it is.
We're kind of mixing levels of abstraction. This stuff is all at a pretty high level of abstraction, and then suddenly we're way down in the weeds.
Yeah.
And I think things tend to be easier to understand if they are all at a similar level of abstraction. Um, so let's see. What could we do about this? What does this mean? Left child and right child. So if we have, for example, an expression like this, 6 and x plus 3, um, I'm not even really sure what that's doing. I think maybe it's just like splitting it into the 6 and the x plus 3.
Hmm.
Um, okay, and I'm not sure what I'd call that. Let's take a closer look at what this actually is. Okay, so it splits it into 6 and oh, that's interesting.
Mm.
X plus 3 without the leading parentheses, but with the trailing one.
Well,
Okay, so that's just a plain old bug.
yeah.
So how about let's add some test cases to address that? Because I think we should probably fix the bug and then refactor as opposed to the other way around. Okay, let's see. Let's do this context uh, sub expression x plus 3. It has a left child of x.
Mhm.
So maybe we can do this. Let sub expression equal expression dot right child. Expect sub expression dot left child to equal x. Okay, and it doesn't equal x. Oh, yeah, we'll have to do dot value. Oh, it passes. Okay. Yeah, I guess that makes sense. Um, we also want it to have a root of plus. That passes also. So I'm guessing the right child will not pass. We're expecting a right child of 3. Okay, that does not pass.
Okay.
For whatever reason, we get times. And it is a mystery to me why. I'm going to put a binding.pry here and also here. So our values are 6 and this weird x plus 3 thing. And left child is 6 and right child is this structure.
Hmm.
All right, so what do we think of this? Um, the root is plus, left child is x, right child is another tree with a root of times, a left child of 3, and a right child of right parentheses.
Hmm.
Okay. Well, here's something that surely is part of the problem is I'll run this again. The like right hand value is x plus 3 parentheses, not just x plus 3. And it should just be x plus 3.
Right. It's gonna be a regex issue.
Yeah, apparently so. So, um, we'll go to good old ChatGPT and say, give me regex to split 6x plus 3 into 6 and x plus 3. Okay. Who knows if that's going to do the trick or not? I'm not even going to think about it. I'm just going to paste it in and see what happens because I don't want to waste any more brain power than I have to. I don't know what the deal is with that too. I don't know what that means.
Hmm.
Okay. Um, so it gives us empty string and 6 and x plus 3 and another empty string. Okay.
Hmm. Interesting.
Mm-hmm. Okay, when I do this, it gives me it's all correct, except I don't want the empty strings. Oh, okay. So I'll do this match thing instead. Um, okay, so I don't want to do that loop. I want to do this. ChatGPT has a bad habit of coding speculatively. There's no reason to have this if match data. There, okay, that passes, and all the tests pass. Okay.
We have an assumption with we're matching on a digit for the left child.
Yeah, that's fine. We'll add a test case that violates that assumption, and that'll force us to fix it.
All right.
Okay. Get sub expression working. Okay. I don't have a good name for this. I'm just going to call it other parentheses for the moment. Let's do 5 plus b. Okay, has a root of time still, but a left child of, oh, let's change 6 to something else. Let's do a. Left child of a. Right child with a root of plus. Okay. All right, let's just take these one by one. First one doesn't even pass. All right, we get an error because there's no match data. All right, because it's violating our assumption that it's starting with something numeric. Okay, let's make it so the regex would also work with a 5 plus b. Okay. And just for convenience, I want this regex to be a little bit more loosely coupled from this code so I can swap it out when I want to. I guess I'll do that. Shardley, bonjour, mon ami.
Mhm. Bonjour, bonjour.
I guess I should say bonsoir.
Yeah, you got it.
Um, okay. So we're doing a bit of refactoring right now, Charlie.
Okay.
Um, on this expression parser program that I've been working on. Okay, so this part works. So now let's address the sub-expression, which in this case is not x plus 3, but is 5 plus b. Okay. And actually, let's make this part different also. Let's do 5 minus b. And it has a root of minus. Let's check that. Okay, expected minus got times. Okay, that's because we're just hard coding the root at times. Um, or is that why? We also don't have minus in the operators because I don't think we have a minus case anywhere else in our tests. So let's actually add a new one just for subtraction to make life a little easier for ourselves. Okay, expected minus got times. If we modify the operators like so, does this pass? It does pass. Okay, but of course this stuff will still fail. Okay, this one passes, has a left child of 5. Okay, that passes, and it has a right child of b. Oops. I can't believe that actually works. Okay, but then on 177, we have a failure here. Oh, that's just because the test is wrong. Okay. Okay, so that works now. We maybe want to refactor this code, but first I'm just going to commit what we've done here. what did we do? We fixed the regex and we added the subtraction operator. Whoops. Okay. Okay. So Shardley, what I was having my new friend Scott do is just go through this code, and I was having Scott attempt to explain it to me, even though he's never seen the code before. That way we can force the code to be understandable enough that somebody who has never seen it before can understand it. But Scott, unlike before, where you were not cursed with familiarity with this code, now you are. But luckily, Shardley, you haven't seen this yet.
Sure.
Um, so first of all, in case you're not familiar, what this program is a it's an expression parser that will parse a mathematical expression into a tree. So like 5x plus 2, for example, would get parsed into this tree. Um, and Scott pointed out that this first, in this parse method, this first chunk here says, well, if the value we're dealing with is a constant, then just give us a tree with a constant at the root, this current value. If what we have is a variable, just return that. But then what do you think this case is, Charlie?
Let's see. Variable and regex value.
If you haven't figured it out by now, my code sucks.
No, I mean I'm a slow reader when it comes to code in general. So let's see.
No, I mean you should be able to tell within like 2 seconds. So let's figure out a way to make this code clear enough that you can tell within 2 seconds what it is.
Yeah, I guess I should have just look at the return, what it's returning
Mm-hmm.
pretty much, and just returning like a new expression tree with the child stuff like with the root pass stuff passed to it and the ch left child and the right child.
Yeah, yeah, so here it's checking to see if the value includes a left parentheses. And that's basically just a lazy way to see if it has any parentheses in it.
Mm-hmm.
So it'll like take, for example, this 6 times x plus 3 and split it into the 6 and the x times 3. And then, like you said, it'll create a new tree where the left child is the 6 and the right child is, well, the right child is actually a sub-expression of the x plus 3. But really, like I was talking with Scott and Amar earlier, this really mixes levels of abstraction. Like these two chunks here are at a pretty high level of abstraction, but then suddenly it's like, okay, this is clear if it's a constant, if it's a variable, and then suddenly you're slapped in the face with all this regex and stuff, all this like really low level stuff.
Mm-hmm. Mm-hmm.
So I think that makes it harder to understand if it's at different levels of abstraction. So what if it's something more like this? That might be a different, or that might be a decent start. See if the tests still pass. They do. So I'm going to commit just that. Okay, and how can we abstract away this regex stuff? I think that's a bit of a tougher question. First of all, this is kind of bugging me. I think we can simplify slightly by doing this. Okay, so that's slightly easier on the eyes, I think.
Mhm.
Okay. Now, basically, this regex is just taking like, it's taking what's inside the parentheses and what's outside the parentheses. Yeah. Okay. I'm going to take what I just did and undo it. Because I think we can say like value before parentheses and value inside parentheses. Okay, and that still passes. So now it makes it a little bit more clear what's what.
Okay, yeah, that makes sense. Yeah, okay.
Yeah, so I'll commit that. Um, okay. Okay, and Scott is back. Um, okay. Scott, you missed some amazing shit.
I'm
Yeah.
sorry to hear that.
Yeah, it was like a once in a lifetime kind of thing. It just really can't even be explained. So
Mm,
I'm sorry. You'll miss it
yeah, well,
forever.
yeah, don't hurt yourself trying to explain it for me. I'll be okay. I'll find a way past
Yeah.
it.
It didn't even have anything to do with computers. It was just
Yeah.
I asked Charlie like what's the secret of life and he just like blew our minds.
Oh
And
man.
but yeah, it can't really once it's said once, it can't I don't know, it's a whole thing. Anyway, um slightly less significantly, we refactored this method. Now it says if contains parentheses. Hopefully that's a little bit clearer. And then these two values, I gave them names, value before parentheses and value inside parentheses, because that's what they are. There's still
Cool.
an unsolved issue, which is that this chunk inside the conditional is still voluminous and noisy. So how do we deal with that? I think this part is fine. Like I can't really imagine how this part could be improved further. It's more this part.
Mhm.
One small thing that could be done if we wanted to would be we could move this out of here and like up to here into a constant. And that might help a little. And then also, for example, like we could move this into a method or something like that. But if we start doing stuff like that, then we give ourselves a new problem. Because right now, all this parentheses related stuff, even though it's noisy, at least it's cohesive. It's all in one place. But if we start moving it to other places, then A, this chunk loses cohesion, and B, the rest of our class loses cohesion too, because now instead of having to worry only about this pretty global stuff, now it's polluted with these like really peripheral concerns that only have to do with the case of parentheses, which is only the case some of the time, not all the time.
Mhm.
So what if we had a concept of like a parenthetical expression or something like that? I don't know if that's a good idea or not, but it's at least an idea. Hmm.
What's a parenthetical question? What's that?
Oh, just something containing parentheses. That's just that's not a term of art. That's not anything anybody ever says. I just made it up just now. Um, which is maybe a reason it's not a great concept. But let's keep thinking on this. Hmm. If it contains parentheses. Let's see. Well, let's give it a try. Parenthetical expression. Okay, and so, whoops, return parenthetical expression dot new value dot parse. Okay. And here we'll have a similar initialize. Oh, yeah, there we go. Don't need to have a conditional because we already know that it's a parenthetical expression. Okay, let's give that a try and see what happens. Catastrophic failure.
Mhm.
Okay, uninitialized constant parenthetical expression. Not too surprising. We need to include it. Okay, it still says that it doesn't know what we're talking about. So what am I doing wrong? Oh, it says parenthetical expression. I need parenthetical expression. Okay. And I do need that require, right? Yeah, I do. Okay, but that works. I will commit this. Okay. And now, because this is in a class, we can refactor some of the stuff into different methods. I don't know, def match data. And now we can put this in a constant, and that is good and appropriate. Okay. Does this
Cool.
still pass? Sorry, did you say something, Scott?
I don't know. It's looking good.
Yeah. Okay, and we can move this. Okay. Everything still passes. Wonderful. I feel good about all that. And significant point, I didn't change my tests at all because of this parenthetical expression class. I might, but I don't feel a need to right now. I think it's an advantage to have a test that's not too tightly coupled to the implementation. Okay. Something I'm curious of is what if the parentheses are on the other side? Whoops. So what if we have like parentheses in front? And so instead of this, it's like 5 minus b times a. That's weird. Does that ever happen? I don't know.
Good, right?
Yeah, in
Feels
theory
like
it
it
could.
comes down to human preference.
Yeah. Okay. But it would be more idiomatic to express it as a times 5 minus b, right?
Hmm.
But you know what? Something should happen. Like, we should, even if this is not valid, something should still happen. Okay, so when we do it like this, it doesn't work. Um, but I don't know if I want to make this case a priority. It just seems too weird. So let's not make this a priority. Let's do something different. What about nested parentheses? That seems more common.
Yeah.
2 times x plus, no, 2 times a plus b minus 5. Okay, that would still have a root of times, I believe. Okay, and that does not work. And let's see why. Okay, so at the top level, if it contains parentheses, then it's a parenthetical expression, and we're not going to concern ourselves with anything more beyond that. We let the parenthetical expression class handle its own parenthetical business. So I'll put a binding.pry here. Okay, it's not surprising that that's what the value is. What is match data? Okay, so match data 1 looks correct. Match data 2 looks wrong. So let's clean this up a little. Okay, so match data 2, oh, I see. It doesn't just chop off the last parentheses, it chops off all the ending parentheses. Okay, so I'm going to do something kind of crazy. I'm going to take this entire test file and paste it into ChatGPT. I'm going to take this whole expression and parenthetical expression and paste it in. And I'm going to run the tests. And I'm going to paste in this failure. And I'm going to see if ChatGPT is smart enough to figure it out. And actually, let's change models here. Let's go to O1 preview, which is supposedly smarter.
Hmm.
Analyzing Ruby code, identifying the issue. Interesting. Hmm.
Cool.
Yeah, this is interesting.
Hmm.
Side note, I'm an enthusiastic user of ChatGPT, but I never ever use GitHub Copilot. I think stuff like this is a much better use case for ChatGPT than the GitHub Copilot like super autocomplete.
Hmm.
Okay. Wow, this is interesting.
Yeah.
It's taking a completely different approach. Can't say I love it. Okay. I have a hunch that all right, so forget ChatGPT's response. It is useless as far as I can tell. I think what we need is some nesting, some recursion, because we have a parenthetical expression inside the parenthetical expression. I think we need to keep parsing the parenthetical expressions inside until we reach the bottom, until what we're dealing with is not a parenthetical expression. So I think I want to do this. Yikes, I really screwed something up. Yeah, this needs to be a class method. Okay. So now I moved the responsibility for telling if something has parentheses. Actually, this, let's not get overly fancy. Has, okay, contains parentheses. Okay. And here we can say if self.class.contains parentheses value, then we'll do one thing. Otherwise, we'll do a new expression tree. Oh shit, let's see. Maybe I am thinking about this wrong. I don't think we need to check because we're already checking here. So we just need to get, we just need to make it so the value inside parentheses is correct.
Yeah.
All right, so let's drop down a level and let's do this. Uh, Parenthetical expression spec.rb. So now I am going to write some tests directly for parenthetical expression. Okay, and I'm going to write a nested parentheses scenario here. And I'll just do a parenthetical expression. Okay. Oh, this should be an E, not an I. Okay. Um, and what do I want to say? Let's do this. Describe value inside parentheses. It is A plus B minus 5. Yeah, it's A plus B minus 5. Whoops, I don't know why I messed that up. A plus B minus, sorry, A plus B minus 5. Okay, and that method is not public, so we'll have to make it public. All right, so that fails. Maybe we can do this a simpler way. Um, we could, let's try this. Let's do value dot split on left parentheses, and we'll take the second element. It's not going to give us the right thing, but it'll give us something. Undefined method value inside parentheses for expression tree. Okay. So parenthetical expression dot parse will give us an expression tree. Oh yeah, we don't want the dot parse. We just want that. Okay, so it doesn't give us A plus B minus 5. It gives us A plus. Oh yeah, that makes sense. Okay, so that's not going to work. What if value inside parentheses? What if we just do match data 2? What does that give us? Okay, that gives it to us without the final parentheses. Okay. So now maybe ChatGPT will be smart enough to handle this because we've narrowed the scope a bit.
Mhm.
Let's see how it handles that. And it is a little bit after the hour, so I'll have to end the session shortly. Okay, well, this is doing its thing. We can race it to the answer. I do not understand this regex. Let's see, rubular. Hmm. That maybe works.
Yeah.
ChatGPT is still not done. Obviously, that's a much simpler regex. Oh, I think we don't have to escape if we're doing it like this, right? Okay, what do we get now? Got nil. Okay. I think I did something wrong. Do I have to escape the parentheses? Whoops. Got nil again.
Hmm.
Okay. Okay, ChatGPT gave us something. Hmm. Looks too complicated. All right, I'm gonna go back to the other model. Give me some Ruby code that will parse that using the above regex. Okay. Whoops, didn't mean to do whatever I just did. Okay. Um, yeah, I think my regex was just like not nearly what it needed to be. See what that gives us. Okay, that passes.
Hmm.
Okay. It doesn't make everything pass, which is not surprising. Oh, I was interested in this, wasn't I? Yeah, okay. So value inside parentheses passes. What about just all this parentheses stuff in general? Okay, that doesn't pass. Undefined method right child for x plus 3 string. Yeah, so this doesn't need to be a string. This needs to be an expression. But this is actually this is I should have done it like this because I want to make a clear distinction between the idea of a value and an expression. Okay, this still passes. Uh-huh. Okay, and that passes. Wow, everything passes.
Right.
Okay. Well, that's kind of a surprise. Um, Okay, I don't even know what I just did. Oh yeah, I got nested parentheses working. Allegedly.
Good start.
Okay. All right, I'm going to wrap up in just a second, but let's see. It has a left child of 2 is what it should have. Okay, that passes, not too surprising. Has a right child of plus. Okay. We expected plus and got 2. And I do not know where that, I don't know why that is. And that seems like a good stopping point. Now, next time we pick it up, um, it'll be clear where to start. Okay, but what did we accomplish in this session? We, for one, we raised the level of abstraction. This is the same as before. It said constant, but now instead of saying if the length is 1, which it said before, now it's asking if it's a variable. And now we're saying if this contains parentheses, then it's a parenthetical expression. And we moved all of the parentheses business into this parenthetical expression object so that all that behavior can be encapsulated in one place, and this is a cohesive chunk of code where everything is all on the same topic. So, and you know, we also added some new behavior. We got the parentheses stuff working a little bit better. We still have a ways to go. We haven't dealt with this at all yet, which we will later. We haven't dealt with that either. But I think it's pretty good start. And just so you know, you can find this at github.com, Jason Sweat expression parser. If you look that up, you can see all of the code for this project.
Nice.
Cool.
Yeah, well, thanks guys for joining me, and I will see you next time.
Thanks, Jason. It's a pleasure.
You guys.